Good morning to all of you. Last class, we have seen the image formation in the case of plane mirror. I think all of you can remember the nature of image formed. The image nature is virtual erect. The size of the image is same as that of the object. Distance of the image is same as that of the distance of the object from the mirror, and it is laterally inverted. So today we are going to discuss about the principal focus of spherical mirrors, that is concave mirror and convex mirror. Principal focus. It is usually represented by capital letter F. So we'll see the corresponding diagram for that. Principal focus. Principal focus of a mirror. So we have concave mirror, convex mirror, the center of the mirror, we know it is pole. P represents the pole. Center of curvature is represented by C. For a concave mirror, it is on left side. Convex mirror, it is on right side. And we draw principal axis. I think all of you remember that principal axis. It is a straight line passing through center of curvature and pole of the mirror. This is the straight line passing through that. And here also, straight line passing through P and C. We call it as a principal axis. Last class, we are seeing this point. It's a principal axis. Next is, if an object is at far distance, for example, infinite distance, example, the sun, the rays are parallel to principal axis. So I write here object at infinity, object at infinite distance, very far. Then the rays are parallel to the principal axis. So rays are parallel to principal axis. I am going to draw the rays here. These are the rays parallel to principal axis and they are parallel to themselves. To show that they are coming from very far distance, I am giving some dotted lines here. Some dotted lines are marking here. So the rays are coming from infinite distance. Okay, for example, light rays coming from the sun. After reflection, so these are the rays parallel to, you can see that these are the rays parallel to principal axis. So these are the rays parallel to principal axis. Okay, then after reflection from the mirror, they are coming to a point, converges to a point. They are coming to this point. Okay, first ray is coming here and second ray is coming here. So these rays are converging to this point, and the other two, they are coming from here. After reflection, these rays are converging to this point on the principal axis. So this point on the principal axis, we call it as principal focus, represented by capital F. So you can see in the case of a concave mirror, object at infinite distance, example, the sun, etc. The rays are parallel to themselves as well as parallel to principal axis. After reflection, all the rays are converging to a point on the principal axis. This point we call it as principal focus. You are supposed to draw these diagrams in the copy. Okay, neat and clean diagram. So this point is known as principal focus. Next, the distance between the pole and the principal focus of the mirror, we call it as focal length. So that I am going to mark here the distance between pole and focus. Pole and focus. That is called focal length. That is PF is equal to F. It is called focal length. Okay. The distance between pole and focus is known as focal length, and distance between P and C, I think you are already familiar with that point. It is called radius of curvature. radius of curvature. So this is for concave mirror. Now we see for a convex mirror. Again, rays are parallel to principal axis. Object is at infinite distance. Two rays on the top and two rays on bottom. I am marking here. Two rays are here. They are coming from infinite distance. You can put two dotted lines. Object again at infinite distance. So two rays I am showing here down, and they are coming from infinite distance to show that we can put some dotted lines. Okay. After reflection, what will happen? They cannot go on right side. So, but they reflect by obeying the laws of reflection, and it comes in this way. This is the way. First ray is reflected back, and it appears to come from a point. If you extend this ray, extend this dotted line you have to put, so it extends backward. So it appears to come from a point here. Similarly, the second ray also I am showing here. This is second ray and extend it backward. Similarly, from the top portion, so the ray is reflected back in this way and appear to come from here. Another ray is also after reflection from here, it goes like this and appears to come from here. So this point on the principal axis, we call it as principal focus. So in the case of convex mirror, so what you can see is here, rays parallel to principal axis. The rays are coming from infinite, that means object at infinite distance, example sun, etc. After reflection, these are reflection points. The reflection ke baad they are going in this way. Okay. So these rays appear to come from a point here. Suppose you are standing here on left side. Okay. Suppose you are standing on left side here. So you are standing here on left side, and for you can see that these rays appears to come from a point F. So this point F is known as principal focus for convex mirror. Again, the distance between pole and focus, we mark it as a principal focal length. Distance between pole and focus, we call it as focal length. So PF distance is called F, again focal length. So we have to consider the object on left side, and you see when the object is on left side, where is the position of the principal focus in the case of concave mirror? It is on left side. Okay, it is on left side, and in the case of convex mirror, the principal focus is on right side. So this is the way how we explain principal focus. Diagrams are a very important one. It's a board question. So define together for concave and convex. So all of you listen the definition. So rays parallel to principal axis. Rays parallel to principal axis after reflection from concave mirror converge to a point on the principal axis. This point we call it as principal focus. And in the case of convex mirror, rays are parallel to principal axis after reflection appear to come from a point on the principal axis. This point is known as principal focus. The distance between P and F, pole and focus, principal focus, is known as focal length. It is the length, so its unit will be, so focal length ka unit hai meter or centimeter, meter or centimeter. So you have to remember this point. It's the length. So P to F distance is focal length of a mirror, and P to C, it is radius of curvature, usually represented by the letter C. So you can remember 2 points here. P is radius of curvature R, and PF is focal length, and we write the equation. The relation is focal length is equal to half the radius of curvature of a mirror. It's a very, very important relation for 1 mark question. Focal length is equal to R by 2, and this value remains constant in all medium. Even if you keep the mirror in water or any other liquids, any medium you keep, the focal length of mirror remains constant. It totally depends upon the radius of curvature. Once the radius of curvature is fixed, वो change नहीं होता है. Okay, So definitely all of you should complete the diagram in the copy this. Okay. The next we are going to explain deviation produced for the reflected ray in all the three types of mirror. So last class we have seen the loss of reflection, angle of incidence equal to angle of reflection, incident ray, normal and reflected ray all lie in the same plane. Okay, it is applicable for plane mirror as well as spherical mirrors. So we have seen the last video. So today I am going to discuss the deviation produced for the reflected ray in all the three cases. After that, we will go for image formation for concave and convex. Okay. Next is deviations. So I am going to repeat the diagram for plane mirror, concave mirror, convex mirror, the reflection. So this is your plane mirror, and you know the nature of image formed by it. This is your concave mirror, and this is your convex mirror. Yeah. You have to take a point and draw the normal to this point. So I am taking a point P. Let it be center. Okay. Draw normal perpendicular to the point. It's a normal. These are the lines not normal. Marking N. N stands for normal perpendicular to the point P on mirror surface. The next is I am going to draw incident ray. Okay. Light rays reaching to the point P at this way, on this way. This is called incident ray, and you know angle between incident ray and the normal is known as angle of incidence. Obeying the laws of reflection, it reflects back in the same medium. So therefore there is no change in the velocity, no change in the frequency, no change in the wavelength, and you know this point. I is equal to R. So in all the cases we can draw this diagram. It is already with you. This is your incident ray, normal के बीच में angle of incidence, reflected ray RR, reflected ray, this angle is R, I is equal to R. Same is applicable for convex also, incident ray at the point P, normal का बीच का angle is angle of incidence. This reflects in the same medium, and this is a reflected ray R angle between reflected ray and the normal I is equal to R. So we have seen this point. So one more point I am adding this. What is the deviation? Deviation means it is the angle made by the reflected ray with the initial direction of incident ray. So what is the initial direction of incident ray? We'll see the diagram here. So this is your incident ray. It cannot go further because of the reflection. So I am extending incident ray in this way backward. This is the incident ray. Incident ray is extended backward. This is the incident ray direction. From incident ray direction, what angle the reflected ray is going? This angle we call it as a deviation letter D. Okay. Initial direction say initial direction of incident ray to the reflected ray. This angle I am marking as deviation. So deviation means deviation by the reflected ray is the angle made by the reflected ray with the direction of incident ray. Angle made by the reflected ray with the direction of incident ray. This is the incident ray ka direction aise ja raha hai. From here we have to make this angle to the reflected ray. So this angle is called angle of deviation. This is the initial direction of incident ray. From here we have to mark this angle deviation. This is the initial direction of incident ray. From here you mark the angle to the reflected ray. This is angle of deviation. So what is the value of this angle of deviation? You can see that I is equal to R, and this total angle is 180. From this angle and this angle you have to subtract. So deviation is equal to 180 minus I plus R. I is equal to R, you know. So this is 180 minus I plus I. So it is equal to 180 minus 2I. So the deviation produced by the reflected ray is 180 minus 2I in all the cases. So all should write this and also make the diagram in the copy. What deviation? What is the deviation produced by the reflected ray from the initial direction? It is 180 minus 2i. Example for I am writing it is here. If example number 1, if I is equal to 30 degree, what is the angle of reflection? Angle of reflection R is equal to 30 degree. And what is the angle of deviation? Angle of deviation is 180 minus 2i. So that is equal to 180 minus 2 into 30. That is equal to 120 degree is the angle of deviation produced. Example number 2. Example number 2, then I am going to say that suppose a reflected ray is perpendicular to incident ray. This is a common question. Reflected ray is perpendicular to incident ray. What is the angle of incidence? And what is the angle of deviation produced by the reflected ray? Reflected ray is perpendicular to incident ray. Any case, plane mirror, I am taking as example of plane mirror. So what will be the condition? Both are perpendicular. So perpendicular means, so what is the angle? I plus R equal 90 degree. You can see this diagram. Okay, you can use this diagram. This reflector is perpendicular, so this angle is 90 degree. So what you will write it as I plus R equal to 90 degree. But I is equal to R, so we can write it as I plus I, 2I equal 90 degree. So I value have 45 degree. Angle of incidence is 45 degree. So deviation in this case is 180 minus 2I. So 180 minus 2 into 45, that you can write it as 90 degree. Okay. So these are some examples of deviation. So deviation produced is 180 minus 2I, and that is equal to 180 minus 90. So we are getting it as 90 degree in this case. Okay, it's clear. So all of you should complete the diagram in the copy. Next, we are going for image formation in the case of concave mirror and convex mirror. Before going to see the image formation, we should consider different rays for image formation. So what are the different rays we are to consider for image formation? That is the next point. Suppose you have a concave mirror. It's a concave mirror for you. So we can mark 3 points. P is the pole and C the center of curvature. And straight line passing through this is known as principal axis, and this point is known as principal focus. So we can keep the object anywhere, okay, very far distance, infinite distance, beyond C, anywhere we can keep the object here, or we can keep the object at C, or we can keep the object in between F and C, or we can keep the object at F, or we can keep the object between F and P. Different locations we can place the object. And so many rays are coming from the object. Okay, so I am just showing what are the different types of rays. Some are going parallel to principal axis. Some are trying to pass through principal focus. Some are trying to pass through principal center of curvature. Some are going to reach the P at the point. So many rays are coming there. So we consider them separately and see what will happen to these rays after reflection. Okay. So you can keep the object anywhere. So many rays are coming from the object from different parts. So out of that, we consider 4 different cases. Okay, 4 different cases we are going to consider for the image formation. So what are the different rays to be considered for the image formation in the case of spherical mirrors? So first one, case 1. Concave mirror, convex mirror, principal axis, P, C, F, P, C, and F. First ray parallel to principal axis. After reflection from the concave mirror, it passes through the focus. Okay, this is the first one. Ray parallel to principal axis. After reflection of the concave mirror, it passes through the focus. And same case, ray parallel to principal axis. After reflection from the convex mirror, it appears to come from the principal focus. So we put a dotted line here after reflection. So if you are standing on left side, so for you it appears to come from the point F. So this is the first case. You are on left side. So first case is ray parallel to principal axis after reflection passes to the focus in the case of concave mirror. Ray parallel to principal axis after reflection appears to come from a point F in the case of convex mirror. I think this is the first point. You have to draw the diagram and the corresponding sentence refer in NCERT. Next case, case 2. Case 2, concave mirror. Convex mirror. Principal axis. Principal axis. Mark the points. P, C, F, P, C, and F. So we consider ray of light passing through the focus. If a ray of light passing through the focus, so ray of light is coming and it passes through the focus. Yeah. So ray of light passes through the focus. After reflection, it becomes parallel to the principal axis in this way. So what is the second statement? A ray of light, if it passes through the principal focus, then after reflection, it goes back, reflects parallel to principal axis. So this is the case of, in the case of concave mirror, and you can see in the case of convex mirror. So ray of light tending to pass through principal focus. It is coming in this way. So if we extend this ray, you can see that it appears to pass, tend to go through F, but वहाँ नहीं जा सकता है. So if a ray tend to pass through F along this way, so after reflection, it becomes parallel to the principal axis. So case 2, we are taking the second ray. You can see in the case of concave mirror, ray is passing through focus. After reflection, it becomes parallel to the principal axis. And in the case of convex mirror, this light ray is tends to go through F, but नहीं जा सकता है. Either after reflection, it becomes parallel to the principal axis. Now, next one is for case 3. Case 3, concave mirror, convex mirror, principal axis, mark the points P, C, and F. P, C, and F. Third case is if a ray of light is passing through center of curvature. Okay, ray of light is passing through the center of curvature. Suppose this is center of curvature, ray of light coming from the object is passing through the center of curvature. It goes like this. And I think all of you remember any line passing through center of curvature to any point on the mirror surface is a normal. I think you remember the examples of normal incident. So it itself is a normal. So this at this point A, this line is a normal. So light rays going along the normal. So angle of incidence is 0, angle of reflection is equal to 0. It reflects back, returns. अपने रास्ता वापस आएंगे. It returns. Okay. So here it is, the light ray passing through C after reflection from the mirror surface returned, because it is an example of normal incident. I is equal to 0, R is equal to 0. Similar case in the case of convex mirror. So you can see a light ray is coming in this way, okay, but इधर नहीं जा सकते हैं. So it tend to pass through C. When it reaches here, coming back in the way, coming back, retraces. So this is the light ray that is tending to pass through C. You can extend and you can see that it tends to pass through C. It's a normal to the point A. So the light ray from here itself retraces its path. Here is also I is equal to 0, R is also equal to 0. It's normal incidence. So this is the third ray that we consider for image formation. So third ray I am explaining here, light ray passing through C reaches the mirror surface, returns, because it is a normal incidence. In the case of convex mirror, light ray tends to pass through C, again returns or reflects back along the same way, because again it's a normal incident. So three diagrams we are seeing. And the fourth case I am going to remove this page. Okay, all should complete this diagram in the copy. So next one will be case 4. This is your concave mirror, this is your convex mirror, straight line passing through P and C, principal axis P and C, principal axis, F is a principal focus. Okay. In this case is any light ray reaches to the pole obliquely. So we are repeating the previous diagram here. This is the incident ray reaching to the pole at the point. This is angle of incident because principal axis itself is a normal. So principal axis itself is a normal. So ये angle of incidence है and reflects in the same medium by obeying the laws of reflection R. So this is your reflected ray. So we have already seen this definition. So this is the fourth case. Any light ray reaches at the point pole obliquely at an angle of incidence I, reflects in the same medium by obeying the laws of reflection. I is equal to R. Exactly same case in the case of convex mirror. This is your incident ray and the principal axis itself is a normal angle of incidence, and coming back to the same medium by obeying the laws of reflection, that is I is equal to R. So angle of incidence is equal to angle of reflection. So any light ray, this is the way explanation, any light ray reaches the pole obliquely, means at any angle, and reflects back in the same medium by obeying the laws of reflection. It is applicable in the case of concave mirror as well as convex mirror. So these are the 4 rays we consider for the image formation in the case of concave and convex mirror. Okay. So what are the 4 points? You can just get the different points in this. 4 points. So for image formation, we have seen first point, ray parallel to the principal axis. In the case of concave mirror, after reflection passes through the focus. And in the case of convex mirror, ray parallel to the principal axis, after reflection appears to come from the principal focus. Okay, that's the first one. Second, if a ray of light is passing through the principal focus, after reflection becomes parallel to the principal axis in the case of concave mirror, and same case for convex mirror, ray tends to pass through F after reflection becomes parallel to the principal axis. Third case, if a ray of light is passing through center of curvature, then it reflects back. It's a normal incidence. And convex mirror, you can see if a ray of light tends to pass through C, reflects back. Again, normal incidence, I equal to 0, R equal to 0. Last point, if a ray of light reaches the pole obliquely at an angle of incidence and reflects back in the same medium by obeying the laws of reflection, I is equal to R, applicable for both concave and convex. So these are the 4 cases. Okay, and of the 4 rays we consider for the image formation in the case of concave as well as convex mirror. And for the image formation, we require only 2 rays. Any 2 rays we consider for the image formation. So 2 types of images are there, real images and virtual images. What are the properties that we will see? Okay. So these four diagrams all should complete in the copy, and also the sentence are also given statements. Okay, different rays to be considered for the image formation in the case of spherical mirrors. Make a column in that, and concave mirror, four diagrams are there, and convex mirror, four diagrams are there, and you should write the statement also. So main points we have seen in this: principal focus. I think all of you remember the principal focus, definition, and diagram. You have to do in the copy. Deviation produced in all the cases: plane mirror, concave mirror, and convex mirror. That also you have to see. Diagrams you have to complete in the copy, and various rays, different rays, four cases we have seen, that also you have to complete this. So in the next class, we will discuss the different types of images formed by concave mirror, real images and virtual images, what are their properties, etc. Okay, so complete all these diagrams in the copy. Okay, thank you.